Hey everyone, welcome to Math 103. We're working on section 4.4 today on integer exponents and scientific notation. Please start with a warm-up. In this warm-up, we're going to expand and then cancel and see what we get. X to the sixth, that is 6x's multiplied. X to the fourth, that's 4x's multiplied. So there's the expansion. Now we'll cancel matching x's. So all the x's are gone on the bottom. We have 2 x's remaining in the numerator. So that simplifies to x squared. On the second one, we have 2 x's on top and 5 on the bottom. So there's the expansion. Now we'll cancel the matching x's. And what we have left is 3 x's in the denominator. So you've got to create a fraction here. 3 x's in the denominator is x to the third power. Now the question remains, what do we put in the numerator? Well, what happens when we cancel? X over x, does it turn into 0 or 1? It's a common question. What we're doing when we're canceling is we're using the fact that anything divided by itself is 1. So that means we end up with a 1 in the numerator. 1 over x to the third power. We're going to start off today by dividing some monomials. So that means we're going to be using the quotient property of exponents. So when we divide exponentials with the same base, and they have to have the same base, we got y in both the numerator and denominator. Then, when we divide these things, what we can do is subtract the exponents. So this becomes y to the 8 minus 5 power. And that's y to the third power. Your turn, number 1. X to the 12th divided by x to the 7th. Just a reminder, make sure you pause the video so you can work on these at your own pace. So we subtract the exponents, 12 minus 7. So we have x to the 12 minus 7 power, and that is x to the 5th. Now in the next example, we have more than one variable. So make sure to combine only those that have the same base. So we'll do one operation for the x's, and then a separate one for the y's. So this becomes x to the 4 minus 2 times y to the 6 minus 5. And simplifying, we get x squared y. Your turn, number 2. Same situation, we got a pair of x's here and a pair of y's. We're going to combine the x's. Subtracting those exponents, we get 7 minus 4. Now for the y's, 5 minus, and there's no exponent here, so that's just assumed to be a 1. 5 minus 1. And that is x to the third, y to the fourth power. Next up, with this example, we're not allowed to subtract those exponents because we have different bases. We have a base of x here and a base of a here. So we cannot combine those. So that is fully simplified. Your turn, number 3. Again, we have different bases, y and x, so we cannot simplify that one. We'll just leave that as it is. Next thing we're going to learn is the definition of 0 as an exponent. Nice thing about a 0 exponent is it doesn't matter what the base is. It can be any number or any expression. If we take it to the 0 power, the value is always 1. So here's an example. We've got 4x to the 5th power. This is all to the 0 power. Doesn't matter what's inside here. Still going to be 1. Your turn, number 4. So we've got this expression here to the 0 power, 15x to the 7th, y to the 10th. We could have a million variables in there. We could have numbers and roots and pi and whatever. Doesn't matter what's inside there. If we take it to the 0 power, it's 1. Next up, we're going to combine both of these things to evaluate these. So first thing we're going to do is use the quotient property and subtract the exponents. So that's x to the 5 minus 5, which equals x to the 0 power. And we know what that is, that's just 1. Your turn, number 5. Subtracting those exponents, 3 minus 3 gives us 0, so we get y to the 0 power, and that one also is 1. So we've seen positive exponents and 0 exponents. Now we're going to talk about negative exponents. All right, so I'm going to take 2 different approaches to simplifying this. When we do that, we're going to learn what the definition of a negative exponent is. So if I expand and cancel like we did in the warm-up, I'll have 5x's on top and x to the 8th, we'll have 8 on the bottom. Now I'll cancel pairs of x's. We've gotten rid of all the x's on top, so that's just a 1. We have 3 x's remaining on the bottom, so that's x to the 3rd power. All right, now what I'm going to do is I'm going to use the properties of exponents to simplify this one. So subtracting the exponents, 5 minus 8, that gives us x to the negative 3 power. So now we know that this expression equals 1 over x to the 3rd power, and this expression also equals x to the negative 3 power. So what that means is these two things must be equal to each other. And this example shows us then what a negative exponent is. If we have some base to a negative exponent, that's the same as taking this whole expression and putting it in the denominator and turning the exponent positive. In more generic form, 1 over x to the n equals x to the negative n, and Now it might be a little easier to understand if we write these in fraction form. Anything can be written over 1. So what's really happening here is we're taking this expression, we're moving it from the denominator into the numerator. And when that happens, we change the sign on the exponent. From here it becomes from positive to negative. And here the reverse is happening. We've got a negative exponent in the denominator, we move it to the numerator, and it becomes positive. One way to remember that, when you cross the line, change the sign. The line refers to that divisor line. If you move this to the numerator, it becomes x to the positive n. And this can be done in either direction, either moving it from numerator to denominator or denominator to numerator. But whenever you do it, change the sign. Next example. We're going to evaluate 5 to the negative 3 power. So first thing we're going to do is use the definition of negative exponent. So I'll take this expression, I'll move it. If there's no fraction, it's just automatically in the numerator. So I'm going to move this to the denominator. And then the exponent changes sign, it goes from negative to positive. So now I've got 1 over 5 to the 3rd power. So now all we have to do is evaluate this thing, 5 to the 3rd power, and we're done. That's 1 over 125. Your turn, number 6. So we've got a negative exponent, so I can move this to the denominator, and the exponent becomes positive 2. Six squared is 36, so our answer is 1 over 36. Next example, we're going to evaluate some numbers. We've got the same base here, and we have to remember that this exponent, if we don't write it, is a 1. So now we can use the properties of exponents. Negative 4, and since we're dividing, we're going to subtract the other exponent. So negative 4 minus 1. So that gives us 3 to the negative 5 power. Now we can use the definition of exponent, or negative exponent. And that gives us 1 over 3 to the 5th power. 3 to the 5th is 243, so we get 1 over 243. Your turn, number 7. Now we'll subtract the exponents using the quotient rule. Same base. Bases match at 2, so that means we can use subtract the exponents. Negative 4 minus 2, that gives us 2 to the negative 6. Now I'll apply the definition of negative exponent to write it as 1 over 2 to the 6th power. And we get 1 over 64. Now, whenever you're asked to simplify an expression with exponents, we have to make sure to get rid of all the negative exponents, and then it'll be simplified. So we've got this expression here, 5 times x to the negative 4 power. So we're going to use that definition of negative exponents to move the x to the negative 4 power to the denominator. The 5 stays where it is because it doesn't have an exponent. And now this is considered to be fully simplified. Your turn, number 8. Simplify 3 times y to the negative 2 power. All right, take the y to the negative 2 power. It's in the numerator. We're going to move it to the denominator, and the exponent changes sign to positive. And now that is fully simplified. All right, now we've got one where we've got an exponential in the denominator. It's negative. So to simplify this, the things that don't have an exponent, those are just going to stay where they are. 7's going to stay on top. X to the negative 3, that moves up to the numerator and becomes x to the positive 3. And the 4, since there's no exponent on that, that stays in the denominator. 7x to the third over 4. Your turn, number 9. This one, 3 is going to stay on top. X to the negative 5 comes up to the numerator, becomes x to the positive 5, and the 8 stays in the denominator. 3x to the 5th power over 8. Now we're going to start applying these properties to larger, more complex expressions. Next property is power of a quotient. So with this property, what we're doing is we're taking this exponent, which is on this entire fraction, and we're going to apply that exponent both to the numerator and the denominator. And so what we have here is power to a power. It's x to the m to the p. And we saw with power to a power, we multiplied the exponents. So that's where x to the m times p comes from. And with the denominator, we have I to the n, y to the n to the p. So that's where n times p comes from in that exponent. Now let's try combining this with the negative exponent and just see what happens. We have x over y to the negative 2 power. Alright, so I'm going to first use power of a quotient. I'm going to apply that outer exponent to both the numerator and denominator. So we get x to the negative 2 over y to the negative 2. The reason we get negative 2 here is that, keep in mind, if we just have a variable, that's to the first power. And using power to a power, we multiply the exponents. 1 times negative 2 gives us negative 2. 1 times negative 2 gives us negative 2. All right, now we can use the definition of negative exponent. So that means this thing has a negative exponent, which means I can cross the line to the numerator and change the sign. So we have y squared. This goes down in the denominator and becomes x squared. Now we can just do the reverse of the power quotient, and we get y over x squared. All right, that's the first step in reverse. So what that means is x over y to the negative 2 equals y over x to the second power. So if you have some fraction to a negative exponent, what we're going to do there is flip that fraction over. What do we have here? It's called the reciprocal. Right. Flip it over, change the sign on the exponent. So that's something that will be a very important step in some of the problems we're going to see in a moment. So let's use that rule to simplify something like x to the 4th power over y to the 5th to the negative 3 power. It's a good idea when simplifying expressions like this to get rid of the negative powers if possible. So let's get rid of that negative exponent right off the bat. Flip the fraction, so we get y on top, x on the bottom, and then the exponent becomes positive. Notice we do not change the signs of the exponents. We don't change anything on the inside of the parentheses. The fraction just gets flipped over. What changes is the negative exponent on the outside. All right, now we can use power of a quotient to simplify this. So we've got power to a power here. That means we're going to multiply the exponents. So we get y to the 5 times 3 over x to the 4 times 3. All right, power to power, multiply the exponents. And then we'll evaluate this to get y to the 15 over x to the 12. And that brings us to your turn number 10. So first thing, we want to get rid of that negative exponent. So I'm going to flip the fraction over. Y to the 3rd over x squared. And now that exponent becomes positive 4. All right, now we can use power of a quotient. So we'll multiply the exponents. 3 times 4 on top, 2 times 4 on the bottom. Finally, to simplify, we get y to the 12th power on top over x to the 8th power. And that's as far as we go because we've got different bases, so we cannot combine those two. Next example, we're going to combine all these rules together to simplify this expression. All right, so we're back to multiplying monomials here. So we're going to multiply like things together, numbers by numbers. This coefficient by this coefficient. 3 times -7 is -21. All right, now we will multiply a to the -4 times a to the -2. Add those exponents together. -4 plus -2 is -6. So that becomes a to the -6 power. Now we'll do the same thing for the b's. Adding those exponents together, 6 plus -4 is 2. So you have b squared. Last step in simplifying is to get rid of the negative exponents. So I've got one negative exponent. It means I can move this to the denominator, and that exponent will become positive. Everything else is going to stay in the numerator. -21, there's no exponent on that. That's staying in the numerator. B has an exponent, but it's positive, so that's staying in the numerator. Only thing that's moving is a to the -6 is moving to the denominator and becoming a to the +6. So there's the fully simplified form. Your turn, number 11. So first, coefficient times coefficient. -5 times -2 is +10. Now multiply the x's. X to the 7th times x to the -3. Adding those together, 7 plus -3 is 4. So that's x to the 4th power. Y to the 3rd times y to the -6. Add the exponents. 3 plus -6 is -3. So that's y to the -3 power. Now to simplify it, we want to get rid of that negative exponent. 10x to the 4th power stays in the numerator. Move this to the denominator. Make the exponent positive, so we get 10x to the 4th divided by y to the 3rd power. Now to simplify an expression like this, we're going to apply the properties of exponents to the x's and the y's. But we've got these coefficients out front, so let's deal with those first. Always put the coefficients in the most simplified form. This is the fraction 4/10. And if we simplify 4/10 by dividing both the numerator and denominator by 2, we get 2/5. So this is what's going to end up in our final answer. All right, so 4 becomes a 2. And 10 becomes, actually I'm not going to write it like that. 10 becomes a 5. So we have 2/5 times whatever we get from combining the exponentials. All right, now we'll do the x's. X to the 4th over x squared. Subtract the exponents. 4 minus 2 is 2. So that's x squared. Now, A lot of students make a mistake when writing stuff like this. If you want to put it all on the line or something like that, I see some students writing like that. Okay, that's incorrect. Never do that, because that means that x squared is in the denominator. We do not want it in the denominator. There's only two places you can put it. You can put it up here so it's in the numerator, or you can put it right on the level of the divisor line. That just means we're multiplying by x squared. So even though it's on the divisor line, it's still considered the numerator, because we can always write anything over 1. Just put it anywhere except in the denominator. And it doesn't matter if we get a positive or negative exponent, because we'll deal with that in a separate step. Okay, y's. 2 minus 5 is negative 3. So we get y to the negative third power. And once you apply the properties of exponents like this, your answer is always in the numerator. Then, if it's negative, then we'll move it to the denominator. But it's going to start off in the numerator. All right, now we can simplify this thing. Positive exponent, that'll be in the numerator with a 2. So we get 2x squared. And then the denominator, we got a 5 down there. And now the y to the negative 3, that moves to the denominator. And the exponent becomes positive. From across the line, change the sign. So there's our fully simplified result. Next up, your turn, number 12. So we'll start off with a fraction here. 8 over 6. Divide both the numerator and denominator by 2. And we get 4/3. Right now we'll do the x's. X to the 7th, or x to the 4th over x to the 7th. 4 minus 7 is negative 3. So that is x to the negative 3 power. And the y's, y to the 9th over y to the 3rd. 9 minus 3 is 6. So that is y to the 6th. All right, now we'll simplify. 4 and y to the 6th stay in the numerator. 3 is already in the denominator. Leave it there. Now x to the negative 3, we're going to move that to the denominator, and the exponent becomes positive. So we get 4 y to the 6th over 3x to the 3rd. So next up, we've got a little more complex expressions in the numerator and the denominator. And they each have separate exponent, different exponents. So what we're going to do here is apply these outer exponents first, separately, to the numerator, and then 2 to the denominator. All right, so we get 2 to the negative 3 power. Just leave it at that. Then we'll move it. All right, x to the negative 2 to the negative 3. Power to a power, so we multiply the exponents. Negative 2 times negative 3 is positive 6. So you get x to the 6th power. Now we'll do the y. Y to the 3rd to the negative 3. Multiply those exponents to get negative 9. So you get y to the negative 9 power. Now we can do the same thing with the denominator. 3 squared, that's going to be 9 since it's a positive exponent. I'll just go ahead and convert it to a 9. Now we got x to the 4th power squared. 4 times 2 is 8, so that's x to the 8th power. Y to the negative 5 squared. Power to a power, we're going to multiply those exponents. Negative 5 times 2 is negative 10. So we get y to the negative 10. All right, now we can use the quotient rule to combine exponents with the exponentials with the same base. All right, let's start with this first. I'm going to bring this down. Becomes 2 to the 3rd power, which is 8. All right, so 2 to the negative 3 moves down to the denominator, becomes 2 to the positive 3 power, 2 to the 3rd is 8. So that's gone from the numerator. All right, now we'll do the exponential. X to the 6th divided by x to the 8th. 6 minus 8 is negative 2. So we got x to the negative 2 power. Now we'll do y to the negative 9 over y to the negative 10. Again, with the quotient rule, we subtract the exponents. So negative 9 minus negative 10. Since we're subtracting a negative, that's like adding a positive. So it's like negative 9 plus 10, which is 1. So y to the 1st power. All right, last step. I'm going to bring this x to the negative 2 power down in the denominator. Y is going to stay in the numerator. So we get y over 8 times 9, 72. X, and the exponent becomes positive. Y over 72x squared. And there's a, oh, let's print that. Okay, your turn, number 13. So first thing I'm going to do is I'm going to apply these exponents one at a time. Negative 2 to the numerator. So it'll be 2 to the negative 2 power. A to the negative 2 to the negative 2. Multiply the exponents. That is a to the 4th power. Y to the 3rd to the negative 2. Multiply them to get negative 6. All right, negative 1 power on the 4. So we got 4 to the negative 1. A squared to the negative 1. Multiply the exponents to get a to the negative 2. Now we'll do b. B to the negative 4 to the negative 1. Multiply those exponents. Negative 4 times negative 1 is positive 4. So that's b to the 4th power. All right, now with these numbers, we're going to flip them. Because this one has a negative exponent, so I'm going to bring it down to the denominator. This one has a negative exponent, so I'm going to move it up to the numerator. And when we do so, both of those exponents become positive. Okay, we got 4 to the 1st power and 2 squared then. All right, now we'll work on the exponentials with the same base. Got matching bases of a here, so we're going to use the quotient rule, subtract the exponents. 4 minus negative 2 is the same as 4 plus 2. So that gives us a to the 6th power. And there's a, what was a misprint on this one? I mistakenly put y in there instead of b. So let's change this y to a b. Now we can combine them because we have the same base. So, subtract the exponents. Negative 6 minus 4 is negative 10. So it gives us b to the negative 10. All right, now, here we've got 4 on top. 2 squared is 4. 4 divided by 4 is 1. So those are just going to cancel. So that gives us a to 6. That'll stay on top. The b has a negative exponent, so we're going to move that to the denominator. And make it positive 10. So we get a to the 6th over b to the 10th. Next example, got all one big fraction. Now there are a couple of different ways you can approach something like this. One thing I really like to do is to get rid of the negative exponent on the outside right away by flipping the fraction. But in this case, there's actually a better way to go because we have so many negative exponents on the inside. If we just apply that exponent to everything on the inside, it's actually going to turn a lot of those exponents positive. So we'll get rid of a whole bunch of negative exponents by applying this outer exponent to everything on the inside. But before we do that, we might as well simplify first on the inside. Because the last thing we want to do is start taking big powers, or powers of bigger numbers. And if we simplify first, that means we'll need to apply this outer exponent fewer times. So let's see how that shakes out. Let's simplify inside here as much as possible first, before dealing with that thing. First of all, got this fraction here, 8 over 12, and that simplifies to 2/3. All right, so there's our fraction. Now we'll do each of these individually. Right, a is first. A to the negative 3 over a to the 3rd power. Subtract the exponents. Negative 3 minus 3 is negative 6. So we get a to the negative 6th power. Now do the b's. Negative 1 minus negative 3 is the same as negative 1 plus 3. So that is b squared. And the c's, 2 minus negative 2 is the same as 2 plus 2, or 4. So that is c to the 4th power. Now we simplify the inside, but we still have that exponent on the outside, so don't lose that. So now we can apply this to everything on the inside. We have to apply it to the fraction, and then all three of these things. So apply it to the fraction first, that's 2/3 to the -2 power. And now we'll do power to a power with all three of these. A to the -6 to the -2 power, multiply the exponents to get 12. So that is a to the 12th power. B squared to the -2 power, multiply the exponents, b to the -4. I'll multiply these exponents, c to the -8. Now we can start getting rid of all these negative exponents. So first thing we can do here is flip this fraction over. So we get 3/2 to the 2nd power. Flip the fraction over and make the exponent positive. A to the 12th, that'll stay in the numerator. And then these two both have negative exponents, so they're going to go into the denominator. So you have b to the 4th power, and c, that exponent becomes positive, c to the 8th power. And last thing we have to do is evaluate this. So this is 3 squared on top, so that's 9. So we get 9, a to the 12th, over 2 squared is 4, so we get 4, b to the 4th, c to the 8th. Your turn, number 14. So we can simplify this fraction, 6 over 14, divide both the top and bottom by 2. We get 3/7. Now I can simplify the x's. -4 minus 1 is -5, so that's x to the -5 power. Now do the y's. Y to the 1st power over y to the -4. 1 minus -4 is 1 plus 4, so we get y to the 5th power. We got z to the -1 over z squared. -1 minus 2 is -3, so z to the -3 power. And keep that -3 outer exponent. All right, now we can apply the -3 power to everything inside the parentheses. 3/7 to the -3. Power to a power, -5 times -3 is positive 15. So we get x to the 15th power. Now we got positive 5 times -3, that'll be y to the -15th power. And -3 times -3 is 9, so we get z to the 9th. All right, now we can take care of the negative exponents. All right, I'm going to flip this fraction over. So that's 7/3 to the 3rd power. The positive exponents will stay in the numerator, x to the 15th, z to the 9th, and this goes in the denominator. We got y to the 15th. Turn that exponent positive, move it to the denominator. So last thing we need to do is evaluate this. 7 to the 3rd power is 343. X to the 15th, z to the ninth, over 3 to the third, 27. Keep the y to the 15th. So these are some of the most challenging problems you're going to see in the entire class. So if you can handle these, you're in great shape. Next up is scientific notation. So scientific notation is number in this format. You got some number here, A, that's between 1 and 10, not including 10, we want it to be a single digit with some decimal, possibly. Times, that's just multiplication. And then some power of 10, 10 to some integer exponent. And scientific notation is used to represent very small or very large numbers. When we don't want to write out all those zeros, we can shorten things up in scientific notation. All right, so in order to write a number in scientific notation, we're converting a standard number into scientific notation. We got to move the decimal point until we get a number A here between 1 and 10. So let's convert, for example, .38564. We're going to convert this to scientific notation. So if there's no decimal point, it's assumed to be to the right of the number. All right, now we're going to count the number of places we move the decimal. 1, 2, 3. See, it's not far enough because if we put it here, we still have 38. Still too big, so we got to go over one more. If we put it here, we have 3.8564. And that is between 1 and 10. So that's the goal. Now we just need to remember how many places we move the decimal to the left. And that becomes the exponent on the 10. We moved it 1, 2, 3, 4 places. So 4 becomes the exponent. 3.8564 times 10 to the 4. Your turn, number 15. Convert 7,329 to scientific notation. Decimal starts at the right. We're going to move it until we get to a number between 1 and 10. So 1, 732, not far enough. 73.29, not far enough. That's where we want it, 7.329. Times 10 to the, moved it 3 places, times 10 to the third. It also works for really small numbers. So now we want to move the decimal to the right until we get to a number between 1 and 10. So move it once, still too small at 0.476. Move over one more place, now we got 4.76. And that's what we want. Now we got a number between 1 and 10. And we moved it 3 places to the right, but it's not going to be 10 to the third because we're dealing with really small numbers here. So if we're dealing with small numbers, it's going to be negative. Negative 3. If you move it to the right, it's negative. If you move it to the left, it's positive. Your turn, number 16. So for this one, we have to move it 4 places to get the decimal point between the 6 and the 9. 6.98. And we've moved it 1, 2, 3, 4 places, so negative 4. 6.98 times 10 to the negative 4. All right, now we're going to convert the other way, from scientific notation into regular notation. Now, if you're using a calculator, you can just type it in as 3.86 multiplied by 10 to the negative 3 power. And it'll give it to you, depending on how you set your calculator, it'll probably give it to you as a decimal. We're going to do it by hand, though. All right, now, since we have to a negative 3 power, we're going to move the decimal so that this number becomes smaller. Remember, negative decimals mean a smaller number. So we'll move it 3 places to the left. 1, 2, 3. And I'll have to fill in the zeros. We put a 0 here, and a 0 here, and then the decimal goes to the left. So that becomes 0.00386. Now generally, with a number like this, we're going to put a 0 out front, and that makes it clear where the decimal point is. Without this 0 out front, it can be easy to miss that decimal point. Your turn, number 17. Convert 9.214 times 10 to the negative 2 to standard notation. It's negative 2, so we're going to move it 2 places to the right. 1 to get just to the left of the 9, and then 1 more. So that means we're going to need a 0 out front here. So we get 0.09214. Our next example, we're going to convert with a positive exponent. So positive means we're going to make a bigger number. So that means we need to move the decimal to the right 4 digits. So we're starting here. We're going to move 1, 2, 3, oh, we need 1 more 0, and 4 places. That'll bring the decimal all the way to the right. So that's 38,600. Your turn, number 18. Convert 9.214 times 10 to the 5th to standard notation. So we're starting right here. We're going to move 5 places to the right. There's 1, 2, 3. Then we have to add on a couple of zeros. 4 and 5. That gets the decimal just to the end of that number. Let's put the comma there. 921,400. So working with exponents like this ends up being one of the most important concepts in all of algebra. So go practice.